In this tutorial, we're going to show how to find the area of an enclosure where you're given the function in polar coordinates or in polar form. So for this example, find the area of the lemniscate r squared equals 9 sine 2 theta. Step 1. Determine the values of theta, where theta is between 0 and 2 pi, which result in r equals 0. Okay, so when r equals 0, r squared equals 0. And then, since r squared equals 9 sine 2 theta, 0 equals 9 sine 2 theta. So sine 2 theta equals 0. Since the contents of the sine function are 2 theta, we are looking, in this case, we are looking for values of theta where 2 times theta is between 0 and 4 theta. All I did is I took this up here, these boundaries, and I doubled everything. So 2 theta is between 0 and 4 pi. The sine function equals 0 when its contents equal, well, what do we know about the sine curve? When the angle is 0, we know this from the unit circle. When the contents of the sine, or the angle, is 0, the sine is equal to 0. Same with when the angle is pi, the sine of pi equals 0, the sine of 2 pi equals 0, the sine of 3 pi equals 0, and the sine of 4 pi equals 0. And actually every single pi from then on out. But we're only going up to 4 pi. So there are our values. Once again, 2 theta equals 0, pi, 2 pi, 3 pi, 4 pi. Those are the contents here that are going to give us sine of the contents equals 0, where the contents equal 0, pi, 2 pi, 3 pi, or 4 pi. Then what we can do is simply divide both sides by 2 to get theta equals 0, pi over 2, pi, 3 pi over 2, and 2 pi. So these are our limits that we're going to use for our integrals. These values of theta right here. Okay, so on to step 2. Set up and evaluate the integrals which will give the area of the lemniscate. The area of a lemniscate section, so a section just sort of like a portion of the lemniscate, is given by the integral area equals the integral from alpha to beta of 1/2 r squared d theta. Now where did this formula come from? Well, it's just given to us. The explanation of how this is derived is a little bit more complicated. We don't need to really worry about that. We just need to know what it is. So it's the integral from alpha to beta of 1/2 r squared d theta. Okay, but remember that we're given a formula for r squared. In the question, r squared equals 9 sine 2 theta. So what we can do is we can substitute this r squared. We can just put 9 sine 2 theta right in there. The 9 just pull it out in front, and the 1/2 pull it out in front. So now we have 9 over 2, integral from alpha to beta sine 2 theta d theta. Okay, this doesn't look so bad. Now we can go ahead and perform the integral. Integrating gives the integral of sine 2 theta d theta is cos 2 theta, but since we took an integral, we have to divide by the derivative of the inside of the bracket. So the derivative of 2 theta is just 2, so we have to divide by 2. So sine 2 theta becomes negative cos 2 theta divided by 2. So I brought the negative, put out in front. The divide by 2, I put that out in front. So now we have negative 9/4 cos 2 theta, evaluated upper limit beta, lower limit alpha. Okay. So this is what we're going to use repeatedly throughout when we're evaluating each section or each interval. There are 4 separate intervals which need to be evaluated, or you could say 4 separate sections if you prefer. Okay, so the area of the first interval is -9/4 times cos 2 theta evaluated. Once again, I'm using, remember these values that we found earlier on? 0, pi over 2, pi, 3 pi over 2, 2 pi. These are the boundaries that we're using. So we have one interval between these two, one interval here, one interval here, and an interval here. So 4 separate intervals. And the first one is from pi over 2 to 0. So the upper limit, we just substitute pi over 2 in for theta. Pi over 2 times 2 is pi. And then for the lower limit, just substitute 0. That just becomes 0. So cos pi minus cos theta. Or excuse me, cos pi minus cos 0. The cosine of pi, from the unit circle, we know that the cosine of pi is -1. And the cosine of 0 is 1. So -1 minus 1 gives us -2 times -9/4. -9/4 times -2 gives us 9/2. Okay, so that's the area of the first interval, or the first section. Now we look at the second interval. We do the same thing, but this time our boundaries are pi and, upper limit pi, lower limit pi over 2. When we substitute the pi in for theta, we get cos 2 pi. Upper limit, lower limit, we get pi over 2 times 2, which is pi. Cos 2 pi minus cos pi. Cos of 2 pi is 1. Cos of pi is -1. 1 minus -1 is 2. 2 times -9/4 is -9/2. Okay, so what did we do here? We got a negative value for the area. Well, as it turns out, a negative value indicates that this section of the function is in the complex plane rather than in the real plane. As such, it can be ignored. And if you don't quite know what that means, don't worry about it. Just know that when you get a negative value for an area, whenever you're dealing with polar coordinates or a polar function, a negative value for the area can just be ignored. So this -9/2 can just be ignored outright. Okay, on to the third interval. Once again, -9/4 cos 2 theta from 3 pi over 2 to pi. This gives us cos 3 pi minus cos 2 pi. The cos of 3 pi is just the same as cos pi, which is -1. The cos of 2 pi is the same as cos of 0, which is 1. -1 minus 1, -2. And then take -2 times -9/4 to give you positive 9/2. Okay, so this is our next value. Nine halves, alright. So the area of the fourth interval, this time our boundaries are upper limit 2 pi, lower limit 3 pi over 2. Evaluate this, and we get, you go through the steps here, comes out to -9/2. A negative value indicates that this section of the function is in the complex plane rather than in the real plane. As such, it can be ignored. Okay. So this -9/2 for the area of the fourth interval, you can just ignore it completely. And that's it. Step 3. Our final step, combine the area of the two relevant intervals. So the relevant intervals is any time we got positive area. So this 9/2 for the third interval, and this 9/2 for the first interval. 9/2 plus 9/2 gives you 9. And that's your final answer. Okay, I'm going to go ahead and do another example, which is a tiny bit harder, but it uses the same methodology that we just used. Okay, so for this example, find the area of the lemniscate r squared equals 9 cos 2 theta. So instead of sine, this time it's cos. Step 1. Determine the values of theta between 0 and 2 pi, which result in r equals 0. Once again, if r equals 0, r squared equals 0, which means 9 cos 2 theta equals 0, which means that cos 2 theta equals 0. Since the contents of the cosine function are 2 theta, we are looking for values of theta where 2 theta lies between 0 and 4 pi. Because theta is between 0 and 2 pi, we just doubled everything. So 0, 2 theta, 4 pi. The cosine function equals 0 when its contents equal, well, from the unit circle, once again, we know that the cosine function equals 0 at pi over 2, which is when the arm is sticking straight up in the air, 3 pi over 2 when the arm is sticking downward, 5 pi over 2, which is the same as pi over 2, and 7 pi over 2, which is the same as 3 pi over 2. So it starts with pi over 2, and with each pi, keep adding pi to get another one, and so on. But we're only going up to 4 pi, so that's why we stop here. Pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Other relevant boundaries are when theta equals 0 and 2 pi. This is always true. You're always going to have a boundary at theta equals 0 and a boundary at theta equals 2 pi. Okay, so what do we make of this? 2 theta is equal to 0, pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. But since theta equals 2 pi is also a boundary, 2 theta is also going to equal 4 pi. This means that by dividing everything by 2, we have theta equals 0, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and 2 pi. So this time we have 1, 2, 3, 4, 5, 6 boundaries, which means we have 5 separate intervals that have to be evaluated. Okay, so we'll use this in a minute. Step 2, set up and evaluate the integrals which will give the area of the lemniscate. The area of a lemniscate section is given by the integral. Once again, we saw this before. Area equals alpha to beta 1/2 r squared d theta. Substituting r squared, remember that r squared equals 9 cos 2 theta. So we just plug that in here. 9 cos 2 theta. Pull out the 9, pull out the 1/2. You get 9 halves, integral alpha to beta to cos 2 theta d theta. Integrating, the integral of cos 2 theta is sine 2 theta. Not negative, positive. Positive sine 2 theta. Divided by 2, because you have to divide by the derivative of the inside of the bracket. So that 1/2 gets pulled out in front. So now we have 9 over 4 sine 2 theta, upper limit beta, lower limit alpha. Okay, so since there are 6 relevant boundaries, there are 5 separate intervals which need to be evaluated. So we're going to use this 9 over 4 sine 2 theta beta alpha many times over, 5 times over. Okay, so once again, what are alpha and beta? Well, we found it here, where the limits are 0, pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, and 2 pi. For the first interval, it goes from 0 to pi over 4. Take pi over 4, plug it in. Pi over 4 times 2 is pi over 2. 0 times 2 is 0. Sine pi over 2 is equal to, well, what's the sine of pi over 2? Well, that's obviously just 1. And the sine of 0 is 0. 9/4 times 1 just gives you 9/4. Okay, so this 9/4 is the first area that we are looking at. Okay, so what's the area of the second interval? Same deal as before. We just use the new limits. 3 pi over 4 upper limit, pi over 4 lower limit. Do our substitutions. The sine of 3 pi over 2 is -1. The sine of pi over 2 is 1. -1 minus 1 is -2. 9/4 times -2 is -9 halves. We've seen this before. A negative value indicates that this section of the function exists in the complex plane rather than in the real plane, thus it can be ignored. So the negative 9/2, just ignore it completely. Third interval, 5 pi over 4. Upper limit, 3 pi over 4, lower limit. The sine of 5 pi over 2 is the same as sine pi over 2, which is 1. Sine 3 pi over 2, negative 1. 1 minus negative 1 is 2. And 9/4 times 2 is 9/2. Okay, so this is another section that is going to come into play. The area of the fourth interval. Upper limit, 7 pi over 4. Lower limit, 5 pi over 4. This all shakes out to negative 9 over 2. Once again, because it's negative, we can ignore it completely. On to the fifth interval. Upper limit, 2 pi. Lower limit, 7 pi over 4. Plugging everything in. Sine of 4 pi is the same as sine 0, which is 0. Sine 7 pi over 2 is the same as sine 3 pi over 2, which is negative 1. 0 minus negative 1 is 1. Comes out to 9/4. So as we saw, there are 5 intervals. 3 of those intervals, or sections, if you want to call them sections, 3 of them had positive values. 2 of them had negative values. The negative values we can ignore completely. The positive values we have to add up. So going back and looking through our work here, we had a positive 9/4. We had a positive 9/2. And we had a positive 9/4. So step 3 is combine the areas of the 3 relevant intervals. Total area is equal to 9/4 plus 9/2 plus 9/4. Answer 9. And that's your final answer.